This is a hospital in Alaska, and it's sinking, not slowly, rapidly. The ground beneath the ground that's been frozen solid for 40,000 years is melting, and it's taking the building down with it. Right now, across the Arctic, engineers are in a race against time, because the foundation of an entire civilization is disappearing, and what they're building to save it, it's unlike anything you've ever seen. Welcome to the front line of climate collapse. Here is something they don't talk about enough. 1/4 of the northern hemisphere sits on permafrost, permanently frozen ground that's been solid since the last ice age. Except now, it's not so permanent. In Alaska alone, infrastructure damage from permafrost thaw could cost between $37 and $51 billion by mid-century. And that's just one state. Across the entire Arctic region, the costs of maintaining and repairing infrastructure could reach about 30 billion euros by 2060, with Russia alone facing over 20 billion euros in damages. But here's what makes this terrifying. We're not talking about fixing potholes. We're talking about entire cities where the ground is literally vanishing beneath people's feet. The proportion of damaged structures ranges from less than 10% to as high as 80%, with Russia experiencing the greatest share of damage. Buildings cracking in half, roads buckling into waves, airports where runways are collapsing, pipelines that are tilting 7 degrees and still dropping. And here's the kicker. As much as 70% of today's Arctic infrastructure is in the risk area when ground warming from climate change is considered. 70%, that's not a problem. That's a catastrophe unfolding in slow motion. So, how do you build on ground that's disappearing? You fight physics with physics. Meet the thermosyphon. It looks like a simple metal pipe, but it's probably the most important piece of infrastructure, technology you've never heard of. Here's how it works. You bury one end deep in the permafrost. The other end sticks up into the air with radiator fins. Inside is pressurized gas, usually CO2 or ammonia. During winter, when the air is colder than the ground, the gas absorbs heat from the permafrost, evaporates, rises to the top, releases that heat into the freezing air, then condenses and falls back down. It's a passive refrigerator. No electricity, no moving parts, just thermodynamics working 24/7 to keep the ground frozen. They've been used in Arctic engineering for over 50 years, and over 120,000 thermosyphons were installed on the Trans-Alaska Pipeline in the 1970s, which is why that pipeline is still functioning today. But climate change has created a new problem. As winters get warmer, thermosyphons become less effective. The temperature difference between air and ground shrinks, so less heat gets removed, which means engineers are getting creative. They're developing flat-loop systems that spread under entire buildings. Hybrid units that can actively refrigerate when passive cooling isn't enough. L-shaped designs that maximize surface area, and they're racing to install them before it's too late. But here's where this gets really interesting, because while some countries are trying to save their infrastructure, others see melting Arctic ice as an opportunity. In September 2025, a container ship sailed from China to Europe via the Northern Sea route. Through the Arctic Oceanate journey, that takes half the time as going through the Suez Canal. This voyage marked the official opening of the world's first China-Europe Arctic Express container route. China and Russia have finalized a deal to jointly develop this route. In 2024, shipments reached nearly 38 million tons, with container voyages between Russia and China doubling from 2023. And they're not just sailing through, they're building. Russia's militarizing along the Northern Sea route. China is constructing heavy icebreakers and Arctic research stations. NATO has responded by patrolling deep into the Barents Sea and updating military infrastructure. What's happening? A new global economic corridor is coming online. The Arctic is becoming the most contested region on Earth. Not because of what's there, because of what's melting. So engineers are building faster than ever before. But they're not just building to preserve. They're building to conquer. New deep-water ports, designed for year-round ice-free shipping. Military bases that can operate in conditions that were impossible 10 years ago. Research stations anchored to permafrost that may not exist in 20 years. The U.S. military just updated its Arctic construction guidelines. The first major revision since the Cold War ended. They know what's coming. But here is the paradox. The infrastructure they're rebuilding to adapt to climate change could accelerate the very problem they're trying to solve. More ships mean more black carbon on ice, which absorbs heat. More construction means more heat input into permafrost. More economic activity means more emissions. We're in a feedback loop. And every structure we build changes the equation. Engineers now have to design for a future they can't predict. Current engineering designs use 30 years of historical climate data, but this approach is insufficient. They're rebuilding foundations for buildings that might need to last 50 years on ground that might not be frozen in 20. Here's what keeps me up at night about all this. About 500 Arctic villages and cities are located in areas where permafrost is expected to thaw by mid-century. We're not just talking about losing buildings. We're talking about indigenous communities that have lived in these places for thousands of years. About entire ways of life that depend on frozen ground. But at the same time, this crisis is reshaping global power. Control of Arctic shipping routes could shift the entire balance of international trade. Access to Arctic resources, oil, gas, minerals, worth trillions is up for grabs. And the countries winning this race aren't the ones focused on preservation. They're the ones focused on exploitation. The Arctic is future-proofing itself by melting, and we're scrambling to build on top of a disappearing world. The Arctic isn't just melting. It's being rebuilt with thermosyphons and ice-resistant ports, with shipping lanes that didn't exist 5 years ago, with infrastructure designed for a world that's 2 degrees warmer. We're not preventing climate collapse. We're engineering around it. And the foundation we're building, it's not just physical. It's geopolitical. The ground is disappearing. The question is, what are we building in its place? If this changed how you see the future, hit subscribe. Because this story is just beginning, and the Arctic is where it's being written.